Let's get started. So, today we're going to talk about the object-oriented principles and their implementations in Python. Now, you worked with a purely object-oriented language like Java, right? Now, the object-oriented principles are enforced in Java, but Python is not exactly that. It's not exactly like Java. There are some object-oriented features that are implemented, but they're not exactly. Not every principle is enforced. We're gonna look into first that we're gonna look at the difference between the structured paradigm and the uh, the um, the object-oriented paradigm. So when we talk about object-oriented paradigm, it's object-oriented, right? So the main components we're talking about here are the objects, and there is the concept of a class that is the template for the objects. Okay, now before we start talking about how do we implement the object-oriented features, let's see the difference between the object-oriented versus the structured paradigm. Now, generally speaking, we talked about two main components that any computer program consists of, right? No matter how complicated it is, no matter what language it is, no matter what paradigm it is, there are exactly two things in any computer program. Do you remember what are they? They're exactly two components of any program, no matter how complicated or simple it is. Sorry, interpreter? Well, the translation is important, okay? But I mean, in terms of the program itself, the function of the program itself. So the program is written in order to solve a problem, right? So in order to solve a problem with a computer program, we think about two components of this or the solution of this problem. Yes. So input and output are one thing, this is the data. And then there is the processing that applies on this data. So any program, no matter what it is, there are data and there's some processing applies on this data in order to solve the problem, right? Now the different paradigms organize the data and the processing and apply that applies on them in different ways. That's the main difference between one paradigm and the other. It's just a way to organize the data and how the processing would apply on them. All right. So before the object-oriented paradigm became popular, there was the structured paradigm. So the structured paradigm was a great enhancement of over the what was before it. Okay, but at some point, as the programs started to be to get more and more complicated, it like something else was needed. Okay, but the main idea of the structured paradigm, like the main organization of the data and the processing, is that we have the processes implemented by themselves as functions or as procedures. Okay, independent. And then the data will be sent to these procedures to apply the processing and then sent out of the procedures or the functions after the processing is done. So the data and the processes are a little bit independent of each other. Okay, it's not exactly, now the processing expects something to be sent to it to process, and then it will be sent out. Okay, so functions and procedure is just right now it's all functions, because the difference between the functions and procedures is that functions is supposed to return something, and procedure is just applies some processing without returning anything. But at this moment, almost nobody distinguish between both, except for maybe SQL language or a few languages. But now everybody just say a function, and a function may or may not return. Okay, so the processing would be implemented in a function, and then this function would expect something to, the data would be sent to it, and then sent out after it's done. Now, when the data becomes more sophisticated, we're starting talking about data structures instead of data independent or like atomic data elements. We have data structures. Okay, so that's pretty much how it was. Now we have languages like Python and JavaScript are kind of hybrid between structured and object-oriented or object-based. So instead of having data structures, we're talking about objects, right? So we send objects and expect the function to return objects. You know, languages, when language like Java appeared, the people were starting to divert away from this kind of organization. Okay, because it started to have problems, like because the processing is independent of the data, and then if something goes wrong and you try to figure out why there's a data value that is wrong, you don't know which function exactly caused the problem. It was harder to maintain this way. So people started to divert away from the structured into the object-oriented, and that's when the Java started to become popular and the C started to become C++, and so on. But recently, people are like, okay, we don't want to ignore the structured paradigm altogether. It has some benefits. Okay, so new languages like Python now have some features from the structured organization of things, and then we've seen how we can create standalone functions, right? But in the same time, a language like JavaScript that started as an object-based is not a completely object-oriented now, because of the benefits of the object-oriented principles, they started to add object-oriented features to themselves. So now it's more like, okay, let's have something hybrid between object-oriented and the structure. Okay, so we can still have standalone functions, but we have the object-oriented features as well. So how does it look like, the object-oriented features? How is it different than what we've seen when we have a standalone function that's pretty much organized in a structured manner? Now, in the object-oriented paradigm, now these are the principles we are going to cover, but generally speaking, the data and the processing is organized in what we call the object, or so a subset of the data elements that we care about, and the processing that would apply on this data are bundled together in one thing that we call the object. Okay, so we don't have the processing functions independent and then data comes to it. The data and the objects are together. The data and processing are together in one bundle, are encapsulated together. That's the encapsulation idea, in what we call the object. And then the data would be the attributes that describe that object, and the processing will be any operations that we want to apply on this data. Okay, so let's say we want to have we are creating a payroll system. Okay, so one of the objects that we care about are of type employee, or the employees in the companies are the objects that we care about. Now, before the concept of the class was introduced, the people would have tried to create just object for every single instance of that object. It's repeat everything like this. If you have 100 employees, you will have to create 100 objects. But there are a lot of duplication, and duplication is not a good thing in programming. Now we see here they have the same variable names, they have the same code that applies on the same variable. They are only different in the values, right? So we don't want to keep duplicating like this. The concept of the class would solve this idea of duplication, or the need for duplicating. So now we create a template that has the names of the properties, okay, and the code that would apply on them. That's the class. And then we instantiate, so create instances of the template. That's what we call the object. So these two concepts, class and the instantiation. So the instantiation is just the creation of the object out of the class template. Okay. All right, so you can see here there's a variable definition, but we copy the variables every time we create an object. So these variables have the same names, but they are different variables in different memory locations. Okay, and they will have different values as well. All right, so how do we apply this in Python? And so the same concept exists in, you learned about in Java, but the syntax is different here in Python. So the way we create the class is just to use the class keyword. All right, now this class has two attributes, name and the email. If we define the attributes like this, we have to give them initial values. Okay, even though they are meaningless. So now it's just empty strings. Okay. The class ends here. Remember when I said the indentation in Python ends the block? So the class itself, the class definition ends at line 3. Now, how do we create an instance? We use the class, in Java, we used to use the new keyword and then call the constructor, right? So here the new keyword is not part of the syntax here, just the name of the class as a function resembles the constructor concept. All right, and then we can access the attributes using the dot operator. Now we have two objects, right? So two copies of the same class. So there will be a copy of the variable name under the employee emp2 and a copy of the variable email under emp2, different than the copies name and email of the emp1 objects, right? Now there is, you see, like we can create class and we can create and instantiate objects of the class, but there are some features that some people like the flexibility of it, but they might cause confusion. Okay, so here the salary was not defined as part of the class, right? But in Python, if we try to write to a property and it didn't exist, it will be added. Just like if you remember when the dictionary, you wanted to add an entry to the dictionary, it was empty, so we just tried to write to an entry, the key that didn't exist, so the key and the value are added, right? It's pretty much the same here. We're trying to access a property that doesn't exist, it doesn't give you an error. It will add the property and the value to that object only. Now, emp2 still based on the original copy of the class, so it doesn't have salary. So you may have two objects that are supposedly of the same type, but they may have different properties. Okay? Well, in addition to that, you can also delete a property, but this property defined on the class level like this, when you try to delete them using the delete keyword, it just it deletes the value, not the entire property. It sends it back to the original initial value. Okay, yes?
If you were to delete the salary, since it wasn't
part. Yeah, it's probably gonna be, I didn't try.
Okay.
It's probably gonna delete it altogether because it's not part, yeah. Because if you do, yeah, actually, yes, attributes defined this way, we're gonna see that we can define attributes this way inside something like the construction function. And when you try to delete them, it will eliminate it altogether. Okay, yes?
Could we include the name and email in the constructor?
Yes, we can do that, yeah. So that's the other way to define properties. So you see, we can do that from outside, which is, I personally wouldn't recommend doing that. I wouldn't recommend trying to manipulate the properties from outside, but the feature exists. And even if you don't if you don't like doing this, some other people you work with might do it. So you just need to know how it works. Okay?
If going to .salary is not defined, so what would happen if you try to print?
Here it will be printed because it's part of the object. Here it will give you an error. Okay? So it will add it as part of this object, but it's not part of this object. So here we'll give an error, but there it's not. Okay? So because email was defined at the class level. It just deleting would just eliminate the values, but it was, if it was like the salary, it would be deleted altogether and would give an error. All right.